Hello, this is Chad Houston, and I'm just going to sit up here. Today, we're going to be talking about balances and mass. And so, the goal of this activity is for you, the student, to create and build your own balance from just common household items. And the goal of this balance is that it should be able to mass things reasonably well within 10 to 15% error from anything from about 1 to maybe 15 grams of mass. So there's a couple things that we need to talk about. So the goal today, first of all, this will be the PDF of this presentation will be linked in the comments below, along with many other links that you can go to get information on balances and how to build your own. So, first of all, we're going to talk about what exactly mass is, what is a balance in its simplest form, and some of the rules for this lab practical. Now, one of the things I'd like to share with you is if you look over here, here is a link to, which I'll have below as well, to a balance that I built just out of simple school supplies that was probably less than just a few dollars. Things you would have around at home. Here is the results of when I actually went to test it. Here's a second balance I built that was a little bit more involved, where I went to the hardware store. I had to calibrate this one, and here is how it was calibrated, and it was a little more precise and accurate. So first of all, as we go on, we have to think about what is mass, right? Well, mass is the amount of matter in an object. Okay, so what does that really tell us, right? This is typically in units kilogram, and this also is compared to a standard. So essentially, mass is anything that contains matter, and it takes up space. And so the idea is we typically have to compare it to a known mass to figure out what that mass is. And the mass, the units that we typically use is kilogram. Now, the whole idea of standards is actually amazing. And we'll get to that in a minute. But there's also another way to define mass, which I personally like a little bit better. And this definition of mass is basically saying it's the amount of mass in an object, but it's directly proportional to its resistance to force. What does that mean? Well, imagine if you're trying to move something. Let's say you're just trying to move a coffee cup. It's a small mass compared to a car, and you're the force. If you can apply a force to that coffee cup and make it move through a distance, and then you figure you try and apply the same force to a car, and it doesn't move as well as the coffee cup, it's probably saying that the car has more mass. And that's also another way. And so we can quantify pretty easily what those forces are, and therefore we can equate that to the amount of matter in an object, which we call mass. Okay, so the question is, and again, how do scientists do this? If you'd like to look, and I'll go ahead and put a link to this, scientists really care a lot about these standards, whether it's a single atom, and they've been able to do it in a very clever fashion, or it's a whole bunch of atoms. There are ways we can compare a standard. This is a really cool article for, I think, the high school science mind that will talk a little bit about standards and how we can come up with those and why they're so important. It's a little bit beyond the scope, but I just thought I'd put that there anyway. Okay, so let me move this down a little bit. So basically, for a balance, you just need a couple of things. Basically, this is an example of the simplest balance in the world, which you can see is pretty easy to build. There's some sort of pivot point. There's a fulcrum, and there are these two weighing dishes, and that's really all it takes. And if you know the mass in one, then you can figure out the mass in the other. There's ways that you can do that. And so, for instance, so you're like, okay, well then, if we're at home, how do we know what a known mass is? Here's the really cool part. We can use U.S. coins. You see, every U.S. coin has a specific mass in that for that coin. And it's easy to look that up. I've actually checked these, and they're actually fairly close. Over time, it's a little bit less than what's required because, you figure as you put it in your pockets and you wear it and things like, it gets wear and tear. It might lose a little bit, but it's good enough to get us within about 10%, which is pretty darn good. How do we make our balance? essentially you're going to see here in the balances, I made two balances and they all have one thing in common. The first balance is basically just saying, okay, so if we have like just some sort of like, fulcrum, which is what it's called, like a giant lever, a pivot point, two weighing dishes, there's a really important mathematical equation that works fairly well that says the length and the distance here is equal to, I'm sorry, not length and distance, length and mass is equal to length and mass. Okay, and so you can actually change the length and the masses. And so if, for instance, if I have a bigger mass and a shorter length over here, I would have a longer, sort of like a longer length and maybe a smaller mass, right? And those would balance out. So that alone can help us figure out how to, you know, how to find the unknown mass. It's just like solving for x. And the other way we can do it is through calibration. So essentially, here's your job. Bottom line is you need to build a balance. I'll give you an object that you bring the balance to school, or we'll figure out how to do it at home. I'll say, here's the object. Let's go ahead and see if we can find the mass of that object in your homemade balance. I'll compare it to the scales that we have in school. And the closer you get, the higher your grade. And if you do it once and you think, oh man, I think I could fix my balance, you do get a couple of redos, right? Because the goal is we're trying to do this. And you're going to actually use this on experiments that we do. So I would really encourage you. And again, I'm going to have links. I'm going to have links on the bottom here of this video that will help you, and you'll be able to see a couple balances that have been done, get some ideas, and to hopefully get you thinking about how can I build a simple, inexpensive, do-it-yourself balance.